Lesson 5.5, Simplify Algebraic Expressions. Our objective is to simplify algebraic expressions using like terms. When using addition or subtraction signs separate an algebraic expression, into parts, each part is called a term. So in negative 4x squared plus 12 plus x, negative 4x squared would be a term. 12 would be a term, and x would be a term. So you can see that those addition signs are separating the terms. Now that we know what a term is, we can know that like terms contain the same variables with the same exponent. So if you look here, we have 3x squared and negative 7x squared. So we look at their variable, which is x, and then we look at the exponent, which is squared, and so they are like terms. Here we have 8xy squared and 12xy squared. We look at the variables are x and y, and then the exponents are squared. So again, we know that they are like terms. Then we look below, we have 10x squared z and 22x z squared. So x is squared, however, x on this one is not. There is no square there. So they are not like terms. Again, you can look at the z, and the z here is not squared, but this z is. So they have different exponents, which means they are not like terms. A term without a variable is called a constant. So a term without a variable would just be plus 12. That is a constant. Okay, this is out of order from your notes. So I think this is like example 4 or something in your notes. So you might have to find it to catch up. But 4y plus y. We talked about in class that there is always a number in front of this y. If there's not a number written, there's always an assumed number. We know it's there, and that is 1. So then we look, are these variables the same? Yeah. Do they have the same exponent? Yes. So I can take 4y plus 1y. I can add those together because they're like terms. So 4y plus 1y would just be 5y. I circle it, and that is all I have to do. Okay, here I have 6n minus n. Again, that would be 6n minus 1n. 6 minus 1 is 5, so I would have 5n as my answer. I circle it, and that's my answer. Here I have 6n minus 7n minus 4 plus n. When I have a lot of numbers like this, it can look really overwhelming to know what to add together and what not. So the first thing I do is I make it all addition, and I go through and I add the opposite. It just makes it easier for me to see it all as addition problems. And then I make all the n's stand by each other, because then I can see that the like terms are together and the constants are together. So I do 6n plus negative 7n plus n plus negative 4. So I just rewrite it, not a necessary step, but it makes it clear for me, and a lot of kids like it better when they can see them all together like that. So then I do 6n plus negative 7n. That would give me a negative 1n plus n plus negative 4. This n we've talked about has a 1 in front of it, so negative 1 plus 1 is 0. So they are canceled out, they're 0. So all I have left is negative 4, because 0 plus negative 4 would be negative 4. I'm going to circle that, and that's going to be my answer. Okay, 3x minus 5 plus 2x minus x. First thing I'm going to go through and do is add the opposites. Then I'm going to make all of them stand next to each other, just so it's clear to see. So I'm going to do 3x plus 2x plus negative x plus negative 5. I'm going to do 3x plus 2x is 5x plus negative x plus negative 5. 5x plus negative x is 4x plus negative 5. Now, 4x plus negative 5, this is where a lot of 7th graders will be tempted to keep going. Do they have the same variable? No, there is an x here, there is not an x here. So they cannot be combined. So I just circle this, and that is my answer. 7x minus 2 minus 7x plus 6. Again, I'm going to add the opposite, and then I'm going to make the ones that are alike stand by each other to make it easier to see. So I have 7x plus negative 7x plus negative 2 plus 6. So I'm going to add my like terms. So 7x plus negative 7x have the same variable, so I can add them. And the negative 2 plus 6, they have the same variable, which is no variable. So therefore, they can be added. So I can do negative 2 plus 6. So 7 plus negative 7x plus negative 7x is 0x. So that's 0 plus. Sometimes people get confused on that and they want to write 0x. Well, think about it as x is representing any number, and 0 times any number is always what? 0. So that's why 0x automatically becomes 0. So 0x we don't write, we just write 0. And then negative 2 plus 6 is 4. So 0 plus 4 is 4. I circle it, and that's my answer. Okay, I have a long one here. I have 8z plus z minus 5 minus 9z plus 2. So I'm going to go through and I'm going to add the opposite on them. So that's all addition and easier to see. I'm going to do 8z plus z plus negative 9z plus negative 5 plus 2. Then I'm going to go through and I'm going to underline same variable and same variable. What are my like terms? So 8z plus 1z is 9z plus negative 9z plus negative 5 plus 2 is negative 3. And then 9z plus negative z is going to be 0 plus negative 3, which again is negative 3. So I circle my answer, and that's it. For A, the cost of a jacket, J, after a 5% markup can be represented by the expression J plus 5/100 J. Simplify the expression. Then determine the total cost of the jacket after the markup if the original price is $35. Okay, a lot of people will read this problem and they'll automatically freeze because they see percents and it feels like too much information. But they give you exactly what to do. They give you the algebraic expression right here, which is J plus 5/100 J. And we know that there is a 1 in front of this J because I've been pounding it in your heads. And then we look at our variable, and they are both J, and they neither one have an, they have an exponent of 1. So we do 1 plus 5/100 J. So we have 1 and 5/100 J. And that is our simplified algebraic expression. But then they gave us a second part of the question. They said, then determine what the total cost of the jacket after the markup if the original price is $35. So J is representing the original price. So we take 1 and 5/100 times 35. And we get $36.75. So that is how much, after they mark up the price of the jacket, that is how much it would sell for. The cost of a set of DVDs after a 25% markup can be represented by the expression C plus 25/100 C. Simplify the expression, then determine the total cost of the DVDs after the markup if the original price is $40. So again, we have C plus 25/100 C, and we know that there's a 1 in front of this C, so we do 1C plus 25/100 C, which gives us 1 and 25/100 C. And the original price is $40, so we take 1 and 25/100 times 40. And I don't care if you use a calculator on these. And that's going to get us $50. Oh, I should put a dollar sign. And that's it.